Hey guys, today we are going to be finding general solutions to inverse trig functions. So before we talked about finding the one answer that fell within the restricted range of the inverse function, but today we want to know all of the angles that make that ratio. So our essential question is, how do I find all the solutions of an inverse trig function? And one of the most helpful things today is going to be to remember about our all students take calculus, or where things are positive in your coordinate plane. So remember, here is where all of your trig functions are positive in quadrant 1. Sine is the only positive trig function in quadrant 2. In quadrant 3, tangent is the only positive trig function, and then in quadrant 4, cosine is the only positive trig function. So what you're going to see is you're going to see something like this. They'll either give you an expression or they'll say x, and they want to know what angle would make this statement true. What angle has the sine of root 3 over 2? So basically what we're going to be finding is we're going to find an equation for all of the possible solutions and then name the first 3 positive ones that happen. So just like we did with principal inverse values, we're going to go ahead and draw the triangle that would make this ratio. So since it's a positive trig value in here, I'm going to just start it in quadrant 1, knowing my restricted ranges, and I know that's opposite, so root 3 over hypotenuse. And if I recognize these ratios, or I use the Pythagorean theorem, I would know this last side is 1. I think about the angle that would give me this triangle, and that's going to be a 60-degree angle, which is equivalent to pi over 3. Okay, and so when I'm thinking about this, I'm trying to figure out where that is true for all of them. And if you remember back in the day, you know, all of first unit, we talked about coterminal angles. Because if I technically took this angle and I added another 360 degrees to it, it would have the same value. It would have the same trig ratio. And if I added 360 and 360 and 360, I would continue getting that. So in order to write that as a general solution, we're just going to say plus my coterminal. So since I'm in radians right now, I'm going to use 2 pi and then just times it by whatever number you care about. So it's kind of like when we found the domain of these trig functions. Okay, so that's some of this solution. You have to remember that we also have a positive sine value over in quadrant 2. So technically there's an angle over in quadrant 2 that has that same ratio of root 3 over 2. This is a negative one, but it doesn't affect your sine function, which would make then this one have a reference angle also of 60 degrees, or pi over 3. In order to write that, though, we need to remember that we always come from over here on the x-axis. So that angle, in order to find that, we would take pi, or 180, minus my reference angle, which is pi over 3. So if you remember, find those common denominators. 3 pi over 3 minus pi over 3 is 2 pi over 3. So my other solution would then be 2 pi over 3, and again we have to add all the coterminals, so 2 pi times n. That is my general solution. Again, this guy has 2 different places that I can have those angles. Now to find the first 3 positive, I've already found 2 of the positive values, so this is going to be pretty straightforward. I'm going to take my first angle, because pi over 3 is a positive angle. My second angle was 2 pi over 3. And then I can just plug into that formula until I find the next one. Because what I've got right here, I've got this angle, I've got this angle, and now if I go all the way around and hit that angle again, that'll be my next positive value that gets me that function. So if I went ahead and I took 2 pi over 3, and well, I guess I could just do pi, 2 pi over 3 plus 2 pi, right? So I would add 6 pi over 3. That would get me 7 pi over 3 to find that coterminal. Okay, so that is the general idea behind finding a general solution, so let's continue practicing. So number 2, x equals the inverse sine of negative 1/2. So now you notice we've fallen into the negative range. So I'm going to use my restricted range to figure out where my first value is going to be, and then I'll use all students take calculus. So the first one that I know is, remember, the inverse sine falls within negative pi over 2 to pi over 2. So I'm going to draw my triangle down in quadrant 4 because that's where my principal value is. Okay, and so again, it's a sine, so it would be opposite is -1 over hypotenuse is 2. Remember, hypotenuse will be positive. If I use the Pythagorean theorem or I knew my ratios, I would know this other side was √3, and therefore that makes this a 30-degree angle, or pi over 6. Okay, but remember, we went down to get that pi over 6, so I'm going to say that my first general solution would be -pi over 6 plus 2 pi times n. Again, we're just adding to that coterminal. Okay, then we remember my little all students take calculus business, so all students take calculus. Sine is positive up here in quadrant 1 and 2, so my other angle must be over here in quadrant 3. Okay, and so again, if you wrote your ratio out, -1, 2, this side would be √3, and I would find that this is a 30-degree reference angle, or pi over 6. And again, in order to find this guy, we've got to go from my positive way over here, or you could go backwards if you needed to, but remember, this is all 180, so pi, and then if I add the rest of that angle, which was pi over 6, remember this is 6 pi over 6, so my other solution would be 7 pi over 6 plus 2 pi n. Okay, and if you find your first 3 positive angles for here, positive solutions, remember this guy is not a positive solution, so my first positive answer would be 7 pi over 6. Then the next one, if you think about what that would be in all the way around terms, that would be 11 pi over 6 if you remember your unit circle, or if you take this guy and you add 2 pi into it, and then your last one would be 19 pi over 6 because you're going to add that 2 pi, which would be 12 pi over 6. Okay, let's look at a cosine. Again, you got to think about those angles. So we have, this is inverse cosine -1/2. So when I'm thinking about my principal inverses, that falls from 0 to pi. So I'm going to draw mine over here in quadrant 2 because that is where my principal inverse value is. Okay, and so my cosine is again adjacent over hypotenuse, so this will be -1, 2. If I did Pythagorean or I knew my ratios, this would be √3, which then makes this a 60-degree angle, or pi over 3. Okay, don't forget, in order to figure out what this is, we have to go ahead and take pi. Well, I'll move it over here. We're going to take pi and subtract pi over 3 because we want to find that little leftover part, and I would find out that I had 2 pi over 3 plus 2 pi n. Okay, then you think about your all students take calculus. All students take calculus. I'm looking for where cosine is negative, so the other quadrant that's going to happen in is quadrant 3. And then I'm going to go ahead, you can label your triangle and know that this is √3, -1 still over here, and 2. And then you know that this angle is again pi over 3. Okay, if I go ahead and I take pi and add pi over 3, that would get me this entire angle, and I would find out my other solution would be 4 pi over 3 plus 2 pi n. So finally, if I go ahead and find my first 3 positive, oops, don't know what happened there, my first 3 positive solutions, I already have 2 of them, so 2 pi over 3, 4 pi over 3. Take your first one and add your 2 pi, which would be 6 pi over 3, and I would get 8 pi over 3 as my last positive, well, my third positive solution. Okay, let's go through 2 more examples, maybe a little bit trickier with tangent and having one of my quadrant angles. Okay, so we have inverse tan of -√3. So again, remember your principal inverse values, because when I'm thinking on my unit circle, the first place in my restricted range is -pi over 2 to pi over 2. So the first place that tangent is negative is down here in quadrant 4. Again, your principal is going to be in quadrant 4. So I'm going to label my triangle. Opposite is -√3. Remember, if there's nothing under there, it's technically just 1. So I'm just going to put a 1 on the adjacent side. And then I recognize that this will be a special right triangle, 30, 60, 90, and the hypotenuse will be 2. So then when I label and I figure out that this guy is a 60-degree angle, or pi over 3. Remember, I went down to get that, so my first solution would be negative pi over 3 plus 2 pi n. And then I've got to figure out where the other guy is. So remember, all students take calculus. So tangent will be positive over here in 3 and in quadrant 1. So that means I'm over here in quadrant 2. Okay, and again, that's going to be a reference angle of pi over 3 if you put in your ratios. So this is root 3, and this is negative 1. Still would make negative root 3, and then 2. And so then I find this angle. You take pi and subtract pi over 3, and you'd get that it would be 2 pi over 3 plus 2 pi n. Okay, now the one thing to notice here for tangent is because this guy is actually falling on this diagonal, technically this angle to this angle is just pi radians. So an easier way to write this solution would be to take your first angle, which is negative pi over 3, and then just add pi radians, because then you're going halfway around that circle, and halfway around the circle, and halfway around the circle. So if it falls on a diagonal like this, which will happen with tangent, you can just write one solution, which is negative your angle plus pi times n. This did help me find my first 3 positives. So I had 2 pi over 3 was my first positive if I went this way. If I kept going around, I would find that that next angle was 5 pi over 3. And then if I kept going around one more time, or I added another pi, I'd get 8 pi over 3. Okay, and your last question might be, what do you do if you see something that's one of these quadrant border angles? So if I went onto my triangle, or onto my coordinate plane, I tried to draw a triangle. You cannot draw a triangle that has the hypotenuse of 1 and the adjacent side of negative 1. So you have to remember that cosine deals with your x-coordinate, and it's negative 1. And so if I look on my unit circle, this would be the guy where it's negative 1. The other thing that you can think of is if you wanted to do your OIO chart. And remember, this is SOHCAHTOA, 0 degrees, or 0 pi over 2, pi, and 3 pi over 2, or 270. And so if you were looking for negative 1 in cosine in here, you would find it here at 180. So that's a 180 degree angle, or in order to get there in radians, it would be pi. So the one thing to notice here is there's not another place where cosine is negative 1 on your unit circle, because this is the only place that has an x-coordinate of negative 1. So your solution would be pi plus 2 pi n, because I can keep circling around and keep finding that 180 degrees. And then if I wanted to find the first 3 positive, I would just go ahead, the first one's pi, then plus 2 pi is 3 pi, plus another 2 pi is 5 pi, and we've got this. Okay, and so again, if you're trying to find an inverse, you go inside your OIO chart, or you remember that we look for those coordinates, and since this is an x-coordinate, it's at negative 1. Okay, so again, general solutions are going to be an equation, and then you will be asked to maybe find 1 or 2 of the positive solutions, so you can go ahead and just use your formula to find those first 3 positives. I will see you tomorrow.